call is now being recorded.
Okay, so this is part 2 of the 2025 paper 3 Edexcel higher. So it's just starting from question 18. The last video ended on question 17. So let's just jump right into it. Question 18 is a Venn diagram question that was given, and it's got 3 different options. Usually the most common ones is where it has like 2 rings, but this one was a 3-ring one. So Magda carried out a survey to find out the drinks that people like. She asked 100 people, so there should be 100 altogether at the end of your Venn diagram once you've worked it out. And she's asked if they like coffee, which is C, tea represented by T, or hot chocolate represented by H, which we can already see in the Venn diagram below, the relevant letters. So I'm just going to work through the list and just start populating the Venn diagram, because that's what the question's asking for 4 marks. So 32 people liked all 3 drinks. Now, if 32 people liked all 3 drinks, so coffee, tea, and hot chocolate, that's going to be at this intersection here. So I'm just going to put 32 right there in the middle. Okay, 15 people liked coffee and hot chocolate, but not tea. I'll come back to that one. 43 people like coffee and tea. I'll come back to that. So I'm trying to find where it's just only, and I can see this last one here. So 5 people only like tea. So if 5 people only like tea, for tea, we've got 3 intersections. We've got this one, this one, this one, and this one. Now, if they only like tea, it would just be in this section here because it's not relevant to any others. So I'm just going to populate a 5 there. Notice I'm ticking along each information as well, just to make sure I put all of it onto the diagram as well. Okay, let's go back to the top. So 15 people liked coffee and hot chocolate, but not tea. So if 15 people liked coffee and hot chocolate, so that's coffee and hot chocolate, 15 people liked it, but not tea. That's going to be here, actually. So coffee and hot chocolate, but not tea, would be this intersection right there. That one was pretty straightforward, actually. It's not relevant to anything like that. So it's not including tea, because otherwise it would have been in this intersection here. So that intersection is just coffee and hot chocolate. 43 people liked coffee and tea. So coffee and tea would be this intersection here. But we've already got a 32 there. So what we need to do is, we need to do 43 minus 32, because there's already a 32 there. We're trying to figure out what's remaining to put in here. So 43 minus 32 just gives you 11 for that section there. Okay, that's done. 39 people liked tea and hot chocolate. So tea and hot chocolate would be this intersection right here. Again, there's already 32 there, so we need to do 39 minus 32 for that section, which just gives you 7 for that section there. Awesome. Let's tick that one off. 67 people liked coffee. So that means this full section here, that all adds up to 67. Now we've already got 11, 32, and 15. So what we need to do is, we're going to do 11 plus 32 plus 15, which gives us 11 plus 32 plus 15, which gives us 58. So 58 is a total there, but 67 people liked coffee. So we're doing 67 minus 58, which gives us 9. So just 9 for that section. You can always check your answer and add up all them 4, and hopefully it adds up to 67. And then finally, 58 people liked hot chocolate. So this whole section here should all add up to give you 58. So let's do what we did last time. We're doing 15 plus 32 plus 7. So these three added together, which gives us 54. So that gives us 54. But we've got 58 people that like hot chocolate. So we're doing 58 minus 54, which just gives us 4 for that section there. But we're not done, because even though we've ticked all the statements, a lot of students stop at this point. 100 people were asked if they liked coffee, tea, or hot chocolate. None of the statements have accounted for the fact that they don't like any of them drinks, and that would be outside all the rings. So if we add up all these, I'm guessing they will add up to 100. So let's add them all up now. We'll do 9 plus 11 plus 5 plus 15 plus 32 plus 7 plus 4. That gives us 83. So what we need to do to find out how much people do not like any of the drinks, we're doing 100 people, which is a total, minus the sum of what we've just done, which is 83. And that's just going to give us 17. So to demonstrate that, we just write that outside circles. And that's the Venn diagram completed. So that's a nice 4 marker there. Okay, moving on to part B, it says one of the people is chosen at random. Given that this person likes coffee, find the probability that this person also likes hot chocolate. So because we already know that they like coffee, our probability is not going to be out of 100 because 100 is the total amount of people asked. They've already told us, given that this person likes coffee, and we know the amount of people that like coffee, which is right here, is 67 people. So our probability is going to be out of 67. We want to find the probability that this person likes hot chocolate. Now, they have to like coffee and hot chocolate, which could be here. So because that's both coffee and hot chocolate, so it could be that 15. But it could also be this one here, the 32, because that is also the intersection between hot chocolate and coffee. So we need to account for both 15 and 32 on top. So let's simplify that. 15 plus 32 gives us 47 out of 67. And that's for 2 marks. So that's the Venn diagram question for 6 marks altogether. Let's move over to question 19. Okay, there are some sheets of paper in a pile. The height of the pile is 10.4 centimeters correct to the nearest millimeter. So straight away I know that this is a bound question because of that keyword nearest. So that's a big clue that it would be a bound question. The thickness of each sheet of paper, so we'll just highlight, so we've got height and thickness. So the thickness of each sheet of paper is 0.17 millimeters correct to 2 significant figures. Okay, so I know I'm going to be finding out the bounds of both height and thickness, most likely. One other thing I've noticed about this question as well is this is in centimeters and that's in millimeters. So maybe that might be catching you out as well. So just keep that in mind. So these are the skills you should be using when reading a question. It says calculate the upper bound for the number of sheets of paper in the pile. Okay, so if this wasn't a bounds question at all, and I was working out how much sheets of paper are in the pile, I would have got the height of the pile. So how high it is, which they've told us in this first statement here. And I would divide it by the thickness of each sheet of paper. So I'm just going to write thickness of each sheet. Let's write each paper. So that's the calculation I'm doing, but there's bounds involved, so that's the reason why it's 3 marks. So first things first, I'll need to find both the bounds of height and thickness. So I'll write that here. So we're doing height and thickness. Okay, and remember we mentioned the whole units is in centimeters for height, so it's 10.4 centimeters. I want that in millimeters, just because this says millimeters as well, and our second measurement is also in millimeters, so we want them the same. So 10.4 centimeters, I'll just write that up here, is 104 millimeters. So remember, 10 millimeters is in 1 centimeter, so 10.4 times 10 gives you 104. So 104 to the nearest millimeter, so i.e. to the nearest whole number. So adding 1 to this, I get 105, and minusing 1, I get 103. They're not my bounds. My bounds are what's in between these. So what number's in between 103 and 104? That's 103.5. And what number's in between 104 and 105? That's 104.5. If you can't spot that, you can just add the numbers. So 103, add 104, and divide it by 2, if you can't spot what's in the middle of both of them. Okay, so we've got our lower bound and our upper bound for both height. Let's do the same for thickness. Thickness is 0.17 millimeters correct to 2 significant figures. Now, 2 significant figures in this case is a second decimal place. So I am adding 0.01 and I am minusing 0.01 from this number. So adding 0.01 is 0.18. And minusing 0.01 from this, I get 0.16. And my bounds are what's in between these. What number's in between 0.16 and 0.17? That's 0.165. And with 0.17 and 0.18, that's 0.175. Again, if you can't spot that, add the numbers up together and just divide by 2. Okay, so that's my lower bound and that's my upper bound for thickness. The questioner said calculate the upper bound for the number of sheets of paper in the pile. So we know we need to do the height of the pile divided by the thickness of each paper, but we need to decide, are we using the upper bound or the lower bound for each of these numbers? Now, remember when you're dividing two numbers and you want the upper bound of it, you always do the upper divided by the lower. So in this case, we're going to take the upper bound for height because that's what's on top of the fraction, and we're going to take the lower bound of the thickness of each paper. If this doesn't really make sense to you, why am I doing upper divided by lower? Just think, if you've got a fraction and you keep making the bottom of the fraction number bigger, you're actually making the number smaller. So I'll just give you an example just to the side anyway. Let's say, for example, I'm just going to keep 1 on top of all these, just to prove to you that if I make the number on the denominator bigger, sorry, it makes the number smaller. So let's say if I've got a half, we know that a half is 0.5. Okay, let's make 2 bigger. Let's change 2 to a 4. So we've now got 1/4, which is 0.25. So you can just see what's happened here. I've made this number bigger from 2. However, the number's gone smaller. 0.25 is smaller than 0.5. I'll do it again. Let's make the number even bigger on the bottom. Let's say 10. And 1/10 is the same as 0.1, which is smaller than 0.25. So you can see we've made the number bigger each time. 2, 4, 10 is going bigger, the denominator, but the number is going smaller. So that's the reason why we are doing upper divided by lower. So the opposite, essentially. We want bigger numbers in this case, right? We want the upper bound. So I've kind of demonstrated it the opposite way around. Okay, so I hope that makes sense. Let's go back to the question. Okay, so we're doing the upper bound. That's the reason why we're dividing by the lower on the bottom, because if the number is the lowest it can possibly be on the bottom, the number will be the biggest overall, which I've just demonstrated. So I'm going to just write number of sheets of paper in the pile, and just to demonstrate to the examiner, like good working out layout, essentially. So a lot of kids have like they're working out all over the place and it's quite hard to follow. You don't want to be losing marks for that reason. So the height of the pile, we're taking the upper bound, which is 104.5. And I'm dividing that by the lower bound of the thickness of each paper, which is 0.165. Putting that in the calculator, I get 633.333 recurring. You can't have 0.3 of a paper, of a sheet, essentially. So what I'm going to do is I'm just going to say that 633 sheets of paper in the pile, because you wouldn't round up because you've not got another full paper. So you just say we've got 633 sheets of paper. That's the maximum amount we can have. That's the upper bound. So that's for 3 marks, question 19. Okay, question 20 is a circle theorems question. So you should kind of recognize the circle theorems just as you're looking at this circle without even reading the question. A, B, C, D are points on the circle with center O. I can see A, B, C, D are all points on the circumference of the circle, which is important. They're not just free floating. It says find the size of angle OBC. 2 seconds. Okay, so find the size of angle OBC. So which one's OBC? OBC is this one here. I'm just going to highlight it red. This is what we're trying to find here. Okay, that's OBC. Write down any circle theorems that you use and it's 4 marks. Okay, so first of all, there's a few different circle theorems I can see. So I can see there's a cyclic quadrilateral. So we can start off with that first. So remember, the cyclic quadrilateral is where you've got a quadrilateral inside the circle. So we can see that there with each corner, they have to touch the circumference of the circle. Now the cyclic quadrilateral rule says, so I'll just write cyclic quadrilateral. The cyclic quadrilateral rule says that opposite ends of that cyclic quadrilateral. So in this case, 80, and this one here would add up to 180. So to find out angle DCB, all right, angle DCB, I'm going to do 180 minus 80, which just gives me 100 degrees. So I'm going to label it on the diagram as well so I can see it along the way. So that's 100 degrees right there. Okay, so that's the first theorem we've used. The next one that we can use is we've got the angles at the center is double the angle at the circumference. So this angle here, so here's the one that's in the center, and the angle that's at the circumference is 80. So therefore, angle DOB, so this one here, would be double of 80. So 2 times 80, which just gives me 160 degrees. So that's that one there. Okay, now finally, to work out the red one, so angle OBC, I've got a quadrilateral on the bottom, and we know that angles in a quadrilateral, so angles in a quadrilateral add up to 360. Now, if I know I've got 160, I've got 100, and I've also got 43 on the diagram, I just need to add all them up together, and I just need to minus them from 360 to find out what is angle OBC, the red one. So putting that in the calculator, 360 minus 160 plus 100, 260 plus 43, which is 303. And if I do 360 minus 303, I get 57 degrees. And that's my answer. So that red angle there is 57 degrees. That's a nice 4-marker circle theorem question. Okay, moving on to question 21. Got a simultaneous equation question, but it's a quadratics one because there's a squared there. So we've got equation of a circle on the top and we've got a straight line. So we're going to have to use substitution here. So that's the reason why it's 5 marks. Okay, so remember with these questions, you always substitute the one that doesn't have any squares in into the top one. Now what I'm going to do is I'm going to rearrange this equation. I need to either make x the subject or y the subject and plug it into the top equation. Now, because y is already by itself, I'm just going to make y the subject. So I'm going to minus 3x over to the other side to get y by itself. So I get 2 minus 3x. And now what I need to do is y equals this. I just need to substitute for y in this top one here. And the reason why I'm doing that is I want an equation that's just all in terms of one letter so I can solve it. So essentially I'm eliminating the y from the top. So let's do that here. We've got 3x squared plus 2y squared, y which is 2 minus 3x squared equals 44. So we're going to expand, simplify, and solve this equation, but it's perfect now because it's just in terms of x. So we've got 3x squared plus 2 times, I'm going to write this out as 2 brackets, 2 minus 3x times 2 minus 3x, because a common mistake here is kids just say 2 squared minus 3x squared. That's not the case. It's a bracket times another bracket. That's the reason why I brought it out. Let's expand this bracket. So we've got 3x squared plus 2. Just going to put square brackets here. You can keep your curly brackets here. It doesn't really make a difference. 2 times 2 is 4. 2 times minus 3x is minus 6x. And then we've got minus 3x times 2 again, which is minus 6x again. So the minus 6x is minus 12x. And we've got minus 3x times minus 3x. Minus times a minus gives you plus. 3 times 3 is 9. X times x is x squared equals 44. If you don't like using the square brackets, you can just use your curly ones. It doesn't really make a difference. Okay, let's expand and simplify. So we've got 3x squared plus 2 times 4, which is 8. 2 times minus 12x, which is minus 24x. And 2 times 9x squared plus 18x squared equals 44. Now, I've got a quadratic here. And the reason why I know I've got a quadratic is I've got something x squared, I've got an x, and I've got a number. Now, remember, when you've got a quadratic, you must always make it equal to 0. That's just standard rule. You always make it equal to 0 and solve it that way. So let's simplify and bring everything over to the left-hand side. So 3x squared plus 18x squared gives me 21x squared. Dealt with that. Just going to cross it along the way. I've got minus 24x. I want my x's next, so I've done that. And I want all my numbers there as well. So I've got 8, but I've got 44 on the right-hand side. So to bring the 44 over, the opposite of plus 44 is minus 44. So 8 minus 44 gives me minus 36. That equals 0. So we've got a quadratic there, something x squared, an x, and a number, and we've made it equal to 0. Now, what I've also noticed as well is I can divide the whole equation by 3, since all of them go into 3. 21x squared divided by 3 is 7x squared, minus 8x, and then minus 36 divided by 3 is minus 12, equals 0. So I can't simplify that anymore. That's fully simplified now. So I'm going to get 2 answers for x. Now, you could factorize it like normal, which I probably won't even attempt because they're quite ugly numbers, or you could use a quadratic formula. So what is the quadratic formula? The quadratic formula says x equals minus b plus or minus b squared minus 4ac all divided by 2a, where a is what's here, b is what's here, don't forget the minus sign, and c is what's here. So a is 7, b is minus 8, and c equals minus 12. Plugging everything in, x equals minus b, so minus 8, which is just 8, plus or minus b squared, so minus 8 squared, which is 64, and we've got minus 4 times a, which is 7, times c, which is minus 12, which gives us 336. Now, a common mistake people make on the quadratic formula here, if you end up getting a negative answer inside that square root, especially at GCSE level, you've gone wrong. You can't square root a negative number, you'll get an error in your calculator. So that's probably where you've messed up on the signs. So just watch out for that. And it tends to happen because everyone just plugs in numbers straight into their calculator rather than breaking it down. 2 times 8, which is 2 times 7, which is 14. Okay, so then this just gives us 8 plus or minus the square root of, so 64 add 336, which gives us 400. And the square root of 400 is just 20 over 14. So our 2 answers for x, I'll just write them here. We've got 8 plus 20 over 14. So 8 plus 20, so 28 divided by 14 is just 2. So that's our first answer for x. And our second answer is 8 minus 20 divided by 14. So which is minus 12 over 14, which is just minus 6 over 7. So you don't want to put that as a decimal because it goes on forever. So just leave it like that. Okay, so we've got 2 answers for x, but we're not finished there because we need to find our y's. So to find the y's, we need to substitute back into one of these equations and find out y. Now, you can do it into any, but why would you choose the first one? You're just making it complicated for yourself because there's squares there. So I would recommend using this one here where I've already rearranged it and y is the subject. I'm just going to write this down here. Y equals 2 minus 3x. So to find y in this case, I'm doing 2 minus 3 times 2, which is 6. So 2 minus 6, which is just minus 4. So I'm just going to write it like this actually, just so it's a bit neater. Okay, so that's our y value when x equals 2. And our y value here is 2 minus, we're in the calculator, 2 minus 3 times minus 6 over 7. Now you can write it all out and work it out bit by bit if you want to, but I'm just going to plug it all into the calculator, and I get 32/7. And that's my final answer. So I've got 2 values for x and I've got 2 values for y. And that's 5 marks for this quadratic simultaneous equation question. And it makes sense if you think about it. Remember, simultaneous equations are, this is not part of the question, but it's just for understanding. Simultaneous equations, to solve it graphically, is where 2 graphs intersect each other. Now you should recognize that top equation here. I'll do it up here actually. This top equation is the equation of a circle here. So x squared plus y squared equals a number. That's just equation of a circle. So I'll just draw that. Let's just say that's the circle there. And this bottom equation here is just equation of a straight line. It's y equals mx plus c, right? So when we rearrange, we've got y equals, well, if I write like this, y equals mx, which is minus 3x, plus c, which is plus 2. That's just equation of a straight line. So it's a negative gradient going down, crossing through 2. I'll just say it's this equation there. So simultaneous equation, the definition of it is where 2 graphs cross, and you can see that the straight line crosses the circle at 2 points, and this point here is going to have an x value and a y value, and this point here is also going to have a different x and y value. So that's the reason why at the end we get 2 x values and we get 2 y values. So that's not an accurate sketch, but it is a circle and a straight line. So that's the reason why we get 2 answers for each, just in case you wanted some background on that. Let's move over to question 22. Okay, question 22. Circle C is a circle with center 0, 0. The straight line with this equation is a tangent to the circle at point P. So what that's basically saying is this circle has a tangent, which is this. Let's just say, remember, a tangent is a line that touches a circle, which is the equation of that line there. And it's saying that the point P, so this would be P here, is the point where basically the tangent touches the circle. So that's basically what it means graphically. So it's worth drawing graphs if it makes you understand a question. So find the coordinates of P. Okay, so first things first, I'm going to rearrange this equation to make it look like y equals mx plus c, because remember, with y equals mx plus c, we know m is the gradient and c is y-intercept, so I can easily spot that and pull out that information from here. So let's start off with that. I'm going to make this y positive, so I'm going to just write here 3x minus 2y equals 52. So I'm going to bring the minus 2y over to the right-hand side because I want to make it positive. So I've got 3x equals 52 plus 2y. Okay, I want it by itself, so I'm going to get rid of the 52 and put it over to the other side, so I'm going to minus it. 3x minus 52 equals 2y. I'm just going to swap these over. So 2y equals 3x minus 52 because it's y equals mx plus c, not mx plus c equals y. So I've just swapped them over. But y is still not by itself. It's got that 2 in front of it. So to get rid of that 2, since it's 2 times y, I need to divide by 2. So on the other side, so y equals 3 over 2, x minus 52 over 2. So 50 divided by 2 is 25, 2 divided by 2 is 26. Okay, so we've just rewrote this equation into this one here. And why we did that is we can easily spot what is the gradient and the y-intercept. So the gradient is what is in front of the x, which is just 3 over 2. And the y-intercept, so it crosses the y-axis, is just minus 26. So we've pulled out that information. Okay, I'm going to do a little sketch now to help me. So I know I've got a circle with center 0, 0. So 0, 0 is basically the middle of that circle. So I'm quite confident that I can draw a circle. That is terrible. 2 seconds. It's just a sketch anyway. So we can say that's our circle. We don't know where it's going to cross on the x and y axes, but that is our circle because we know the center of it is going to be 0, 0. Now this tangent line, we know that it crosses the y-axis at -26, which is down here somewhere. So it's in this bottom quadrant over there. And we know that it's got a gradient, a positive gradient. So remember, a positive gradient goes upwards like that. If it was negative, it would have gone downwards. So if it's crossing down here and it's got a positive gradient, I can just say that it looks somewhat like this. So it looks somewhat like this. So I kind of sketched it accidentally right in the beginning, because it's quite common that they do it in that position. So roughly that's what our graph looks like. And we know that point P is where the tangent touches a circle. So over here, that's point P that we need to try and find. Now we know the equation of this red line. We've got it here, y equals 3/2x minus 26. We know the gradient of that line as well. Now to find out the coordinates of P, we need another line that intersects at that point, and then we can use the other line to work out what is the coordinates of it. Now another line you should be aware of is the radius of the circle. So I'll do it in a different color so you can spot it quite easily. This over here is the radius of the circle. Now what's special about that is, what does one of the circle theorems say? That tangents always meet the radius at 90 degrees. So this here is 90 degrees. So that means that both these lines are perpendicular to each other. And if they're perpendicular to each other, so I'm going to basically find out the equation of that blue line. If they're perpendicular to each other, that means the gradient of the blue line, so I'm just going to write of blue line, just so you know what I'm referring to. The gradient of the blue line is going to be the negative reciprocal of the red line. And we know what it is of the red line, it's 3/2. So the gradient of that blue line is just going to be change the sign from positive to negative and flip over the fraction. So it's just 2/3. Okay, so we've got the gradient of that radius there, minus 2/3. We don't know where it crosses the, actually we do know it crosses the y-axis. It crosses the y-axis at 0. Because that's the line, it's going straight through 0 because of the radius. So we can say that the equation of that line is y equals minus 2/3 x. Because it's not crossing the y-axis or anything, it's crossing at 0, but I wouldn't write plus 0. That doesn't make sense. Okay, so we've got the equation of the blue line. Now both P sits on the blue line and the red line. We can see here P is on the blue line. Oops, 2 seconds. Nothing there. So P sits on the blue line and the red line. It crosses on both. So to find the coordinates of P in that case, I'm just going to write it here as a little sentence. So both lines cross at P. So I'm going to make the equations equal to each other and solve it, basically, because to find out the coordinates of P, I need to find an x and a y. And I can make both these equations equal to each other because this is y equals that, and this is y equals this. So because they both start with y equals, I can just make them equal to each other. So I'm going to say 3/2 x minus 26 equals minus 2/3 x. And the reason why we've made them equal to each other is a bit like simultaneous equations. You've got rid of one letter, you've got rid of that y. So we're just solving this just for x. Okay, so I'm going to bring all the x's to one side. I'm going to bring minus 2/3 to the left-hand side. So 1.5, so 3/2 plus 2/3 gives me 13/6x equals, I'm bringing minus 26 over to the right-hand side, so it becomes positive. To get x by itself, I need to do 26 divided by 13/6, and that just gives me 12. Now, I'm not finished there because I've only got the x part of the p. I need to also find the y part as well. So to find the y, I just need to substitute into any of these equations, the y ones. I'll choose the bottom one just because that's a lot easier. So y equals minus 2/3 times x, which we know is 12. So therefore y equals minus 24/3, which is minus 8. And there you go, we've got our coordinates of P. I will just put it in red here. Our coordinates of P is just 12, which is the X part, minus 8, which is the Y part. And that's for 4 marks, question 22. Okay, and finally, let's move over to question 23, so the last one. And it's a terrible vectors question, and it's for 5 marks. Okay, so let's jump right into it. OACB is a quadrilateral, which I can see here. There's a quadrilateral. ACP is a straight line. Okay, cool. M is the midpoint of OA. Now, what I'd recommend as you're reading the question, try and figure out certain vectors as you're going along. So M is the midpoint of OA, so meaning that this is half distance and that's half distance. Okay. N is such the point on BC such that BN to NC is 5 to 3 parts. So BN, this part here is 5 parts and NC is 3 parts. Okay, so there's 8 parts altogether and that full line. Okay. OA is A, so O to A, so this full part here is just vector A. OB, so all this going down. Don't forget to draw your arrowheads on as well, so you know the direction is 3B. Okay. And then AC is 2B, so A to C, that's just 2B. Okay, I'm just going to label it on the diagram just so I can see that visually as well. Okay. CP, so C to P, so this section here, I'm going to highlight it, is K times AC, where K is a scalar. Okay, so it's basically you're timesing by that number, so which is going to multiply that out of AC, which makes sense. It's all on a straight line, ACP. And I'm guessing we need to find out what K is. Yeah, given that MNP, so given that MNP is a straight line, so all of them lie in the same straight line. So this is the vector proofs question where we know that MN and MP are going to be multiples of each other, but we'll go into that. So given that MNP is a straight line, find the value of K. Okay, so just before moving further, I just want to explain this part here. Given that MNP, so here's M, there's N, and there's P, they all lie on the same straight line. Now, what that is saying is that M to N, this part here, MN, and M all the way to P, and MP are multiples of each other. So that's the main takeaway from them saying that MNP is a straight line. So M to N and M to P are multiples of each other because of the fact they're on the same straight line. Okay, so that's a good part. So we're going to have to, what I would just say is start finding the values of some of these vectors, and then hopefully it all fits in. So I don't have BC. So let's find BC. I'm just going to start finding vectors. Since it's 5 marks, it's worth getting as much information as possible, and then you can kind of figure out where does K fit into this. So BC. Now, the path, remember there's different paths that you can take to get to certain places. So you could get the same answer by doing a different method as what I'm doing right now. So B to C, the path I'm going to take is BO, and then plus OA, plus A to C. So a good check is make sure your starting and your ending matches the starting and ending on your vector that you're trying to find. So just to reiterate, BC is, I'm going to find BO plus B plus OA plus AC. That's the path I've chosen to take. And always tell the examiner which path you're taking as well. It helps with your working out as well. So BO is the opposite direction of 3B, so it's minus 3B, plus OA, which is just A, and then plus AC, which is 2B. So simplifying that, I'm just going to keep A first because it's in the alphabet first. And then minus 3B plus 2B is just minus B. Okay, so we found BC. We know BC is A minus B. Okay, let's find B to N and figure out where these ratios come into play. So B to N, Now we know Bn is 5 parts out of 8 altogether. So 5 parts out of 8 altogether of all of BC. Okay? Because of this ratio here, B to N is 5 parts, where all of this, that's 3 parts, and that's 5 parts. 3 and 5 is 8 of all of BC. So I'm just doing 5/8 of BC, which we've just found is A minus B. So expanding that, I get 5/8, A minus 5/8, B. Okay, so we found Bn. Let's also find NC as well. So NC is 3 parts out of 8 this time of all of BC. So 3/8 times BC, which is A minus B. Expanding that out, that's 3/8 times A minus 3/8 B. Okay. Now I'm going to use these vectors that I've just found, as well as everything that's on the diagram, to find out both MN and MP, because we know that they all lie in the same straight line. The questions told us that, and we know that they're multiples of each other because they all lie in the same straight line. So hopefully that helps us. So let's find MN first. I'm going to do it in a different color. So line MN, and the path that I'm going to choose to take for M to N, I'm going to do MA plus, and then AC plus CN. So you can see I've ended at CN. So just to check, MA plus AC to CN. Okay, MA, we know that M is the midpoint. So if OA is A, then MA, so this little section here, because it's only half, it's just going to be half A. And then we've got AC, which we know is 2B. And we've got CN, which we don't know CN, but we know NC, we worked out is this. So that means CN is just going to be the opposite sign. So plus, I'm going to change the signs. So it's going to be minus 3/8 A, and then minus minus, which becomes plus 3/8 B. So I've changed the signs because it's CN, but I've worked out NC, so it changes the signs. Okay, let me tidy that up. So that gives us a half A minus a plus and minus 3/8A, which is minus 3/8A, which gives us 1/8A. And then we've got 2B plus 3/8B, which gives us 19/8B. Okay, perfect. So we found MN. We've done that. The next thing we need to find is MP. MP. And the path I'm going to take for MP, so I'll go MA again, AC, and then CP. So MA plus AC plus CP. Okay, MA we know is half A from above. We've already worked out here. AC is 2B, is already there as well. And then CP is K times AC. And we know that AC, so over here, we know that AC is 2B. So I'm just going to say that CP, in that case, is going to be 2 times KB, because K is just a scalar, right? So just to reiterate what I did, CP is K times AC, and I know that AC is the vector 2B. So 2B times K, I can just write as 2KB, essentially, because K is just a scalar. Okay, simplifying this now. I can't really simplify that, actually, because I've got my A's here, and I've got my B's there. So they're together. I can't put that K in. Okay, so we're not done. The question says find the value of K. Now, I know that both these are multiples of each other because they lie in the same straight line. So I can compare the A's together. So I'm going to do it in a different color. I'm going to be comparing the A's together of both of these. And I'm also going to be comparing the B's together of these to figure out what K is, because they're multiples of each other. So first off, I need to figure out, okay, how do I get from 1/8 in MN to a half that's in MP? And what I'm essentially doing is I'm just dividing by a quarter in that case. So I'm going to write that here. I'm just dividing by a quarter. Okay, so to get from an 8 to a half, I'm just dividing by a quarter. Let me just prove that. So 8 divided by a quarter, which is the same as 8 times a quarter, because, no, 8 times 4/1, sorry. Keep change flip, which equals 4/8, which equals a half. Okay, so I've just proved it there. Okay, so just to reiterate, to get from 8A to half 8, you divide by a quarter. Now, if I've divided that by a quarter, I have to do 19/8 divided by a quarter to get my B value here. And 19/8 divided by a quarter gives me 19/2. So this part here, 2B plus 2KB, should be 19/2 in front of B. This should be 19/2B. So therefore, I can say 2, I'll do it in red. I can say 2 plus 2k, so the coefficients in front of the vector b, should be 19/2. So if it equals 19/2, I can solve this equation to find out what k is, which is what the question said, find the value of k. So let's minus 2 over to that side, so 2k equals 15/2. And then finally, to get k by itself, divide by 2, so 15/2 divided by 2 gives us 3.75. And that's our answer. So that's question 23, a vectors question. It was a bit of a tricky one, but if you understand what the question has given you, you can use them facts to help you eventually get to the answer. So I hope that was helpful. You've got part 1 to this video. You've also got the paper 2 as well for 2025. You've got paper 1 as well. And if there are any other videos that you're wanting as well, do drop a message to us as well. And check out all the other videos on our channel as well. But thank you for watching and hope that was helpful.